Okay, so on page 273, go ahead and read this and try to figure it out. I will give you hints, especially if you are going to take statistics, that anytime it says at least or at most, you're going to have to add up several options there. So, and they've already done the probability for you. So go ahead and try to do A, B, and C, and we'll pause it, and you can go from there. Okay, so when it says the probability of winning at least $200, I would be happy with winning 200 or more. So I need to add those two probabilities. And so if you add those together, you're going to get what? 0.000164. How many zeros does this guy have? So 1, 2, 3. And then I think it's going to be, is it the 818? So 818. Okay. And so, you know, that's a lot. So we could round it to the probability is 0.0001. What does that round to? About 65. Okay. Now that's not a percent. That's just probability. If I want a percent, I'd have to multiply this by 100 and get 0.0165%. Now, if you want to interpret what that means, this is kind of hard to understand. Even this percent is kind of hard to understand. So what you could do is say, like, let's take this percent. I could say, well, it's 0.0165 chances to win out of 100, because that's the definition of percent. And then I could scale this up by what? I don't know, like 100. And scale that up by 100. So what would that make that? 1.65 out of what? 10,000. So then I could just round and say, okay, well, that's about 2 chances to win out of every 10,000 chances I play. All right, try B and C's if you haven't already. So, or if you want to pause it again and give it another try after that, go for it. Okay, so the next question is, what's the probability that you just win something? So I'm okay just winning something here. So if I win $1, I'm happy. If I win 10,000. So again, I'm going to add up all those probabilities. Okay. And when I do that, let's see. So like if I have 0.0833, 0.00637, 0.00, and my bifocals are kind of a problem here. And then the other one is pretty tiny. All right. So basically, if I add, you know, even just these first parts, I get 0.089, you know, something. So if I multiply that by 100, that's about, if I move the decimal, so multiply by 100, that's about 9%. Okay. So the probability of winning something is about 9%. And then it says, what's probably that you win nothing? Well, there's two things that can happen. I can win or I could lose. And the probability of winning and my probability of losing has to be 1 or 100%. All right. So if I know my probability of winning something is 9%, and I know that I have to have 100% total, then I could subtract these numbers and get that there's a 91% chance of losing. So I know my chances of losing is 91%. Okay, if you play this game once a week for a year and you win something 3 times, are you doing better or worse than expected? All right. So you win 3 times and you play what? Once a week for a year. So you play 52 times and you actually win 3 of those 52 times. And again, you can have probability in fraction form. Or decimal form or percent. So we'll do a percent this time. So divide, multiply by 100. So that would be about 5.8%. Okay. And then it says the second part of that is saying, are you doing better or worse than expected? Well, if you kind of look at what's expected, we figured out that we would win something would be about 9%. And it looks like we're only winning about 6% of the time. So we're actually doing a little bit worse than expected. All right, so this section we're talking about probability, just some basic probability. Theoretical means it's based on math, not by experimental, like rolling a die over and over and actually just counting real results. Okay, so it's based on math. And again, probability is when you count the number of chances you have to win or to get what you want. Now, again, it doesn't have to be good. So winning could be a positive diagnosis or a negative diagnosis. You know, it doesn't have to be good. So the number of chances to win over the total number of chances. So however many total chances there are. You can read the definition on the bottom of that page, and they kind of give you an example on the top of the next page. And so look at that example and then try to do problem number 2, A and B, on page 274. Okay, so probability, what is the probability of getting a blue marble? So if you think there's this bag and inside it we have, 5 blue marbles and we have, 14 red. And of course we're going to mix them all up so they're not all going to be together in 6 or 9 green. And so we're going to just mix these all up, right? So we're going to kind of, shake the bag. And again, I can't see what's in the bag. So what's my probability of getting blue? So what are my chances of getting a blue? Well, there are, I only drew 3 of them. There are 5 blue marbles. So 5 chances to get a blue out of the total number of chances. So if you take the 5 and the 14 and the 9, right? So that would be 28 total chances. So the chances to get what you want, which is blue, over the total number of chances. And one acceptable answer is a fraction. You could divide it and get a decimal, or you could divide and multiply by 100 to get a percent. So just kind of read my math lab what they want. All right, let's look at the next one. What is the probability of getting a green marble? So there's 9 chances to win, to get a green, out of, again, 28 total chances. So again, you can leave it as a fraction. You could divide and write it as a decimal, or you could divide and multiply by 100 to get a percent. If I said, what's the probability of, say, getting a yellow marble in that situation? Well, there's 0 out of 28. So there's a 0% chance. So I'm for sure going to lose. I am definitely going to lose on that. All right, let's look at the next one down here. It says, find the probability of the sum of the dice is rolled. So with that, kind of like I drew a picture for this one so I could kind of see what's going on. You kind of need to make a chart, and it's what we call sample space, where you kind of list everything out and see what there is. So like if you're rolling a die, you could get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Or you could do 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so forth. All right, so we're going to finish up that chart all the way to 6, 6. And then we're going to figure out what is the probability of getting a sum of 5. All right, so try to figure that out on your own, and then I will come back. Okay, so again, your book did this for us, but I would list them all out. And then I want to know what is the probability of getting a sum of 5. So these are all the possibilities. I could roll a 1, then a 4, or a 4, then a 1, a 3, and a 2, and a 2, and a 3. So how many chances are there to win? There are 4 chances. And then how many total chances are in the whole grid, which is 36. Now, on my math lab, if you put it as a fraction, they're going to want you to reduce that or simplify. So that would be 1/9. If they want a decimal, you divide and get 0.11111 repeating. They might obviously want you to round to a certain point. And then if they want a percent, you would take that decimal and multiply by 100. And again, they might tell you to round to a certain point. So like 11.11% or something. So this answer I don't have to round, so I'm going to go with that one. The other thing is they could say, what's the probability that the sum is, say, greater than or equal to 11? And so if I look at my chart, so I'm not focused on that anymore, greater than or equal to 11. So that would be these guys. So there's 3 chances to have that happen out of 36. I could scale that down and simplify and get 1/12 in fraction form. The other thing is sometimes, especially those of you that are going to take statistics, A lot of times we use the complement, and that complement is kind of what I was talking about earlier, like the probability of winning and the probability of losing all has to add up to 100% or 1. Probabilities can never be negative. They can't be extra credit, like you can't really, really win. So you're kind of stuck between 0, 1 or 0% to 100%, depending on what form it's in. So your probability, the best it can be is 100% chance of winning. The worst it could be is for sure not winning, which is 0, and then everything in between. Can't have negative luck, so to speak. So say I want, what's the probability of having a sum less than 12? That's, if I didn't make out the chart, that's kind of a pain because I would have to count all these up. So sometimes in math what we do is we take 1 minus the probability of this not happening, and we call that the complement. So if I don't want the sum to be less than 12, then basically I want the sum to be greater than or equal to 12, and there's only one way of doing that, 6, 6. So 1 minus 1 chance out of 36, which means I have 35 out of 36 chances to actually win to get a sum that's less than 12. Now, could I count these? Yeah, but sometimes you don't want to count them all. And so figuring out what you don't want, that probability, and subtracting from 100% is easier. An example would be like, what's the probability of people having 1 or more kid? That means I'd have to sit there and find, you know, probability of having no kids, probability of having 1 kid, probability of 2 kids, probability of 3 kids. You know, and there's probably someone there that has 20 kids and more. And so I'd have to find every single person, add up how many kids they have, figure out the probability for each, like having 1 kid, probability of having 2, and so forth. And that's a lot of work. So sometimes, or I guess it's 1 or more kids, so that's not included. So what's easier is to take 100% and just subtract the people that have no kids, probability of having 0 kids. And that would give me everybody else. It would give me all those people. So all I'd have to find is the probability of having no kids, subtract it from 100%, and then I get the probability of having 1, 2, 3, 4, 5, 6, 7, to whatever number of kids. So that's called the complement. It's super handy. All right, go ahead and try on the bottom of page, let's see, in the middle of page 275, try number 3, and then on the bottom, try number 4. Okay, here's that complement thing that we just talked about a little bit ago. All right, so we're going to roll 3 coins. Okay, so again, listing out the sample space is a huge thing. So tree diagrams are your friends in statistics. So I could have heads and tails, or I could have heads and tails for the second roll, or second flip, and I could have heads and tails for the last flip. And so to read these off, you kind of look this way, like heads, 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 tails, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, tails, tail, head, and tail, tail, tails. All right, so then I know all the possibilities. So then I can start answering questions here. So the first one, how many different outcomes are possible when they flip? So I can count them. There's 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay, and they're equally likely, yeah, because they're all the same chance. What's the probability of getting all heads? That only happens once. Heads, heads, heads. So I have 1 chance out of 8 total. All right, what's the probability of not getting all heads? Well, that would be that complement. So if 1 heads is getting, 1 out of 8 is getting heads, 7 out of 8 is not. And I could count those. Those are these guys. Those are your other 7. And then what is the probability? Okay, so see that word at least? What is the probability of getting at least 1 head and 1 tail? All right, so again, you can either count them all, and there's 6 out of 8, which reduces to 3/4. Otherwise, you could cross off the heads, 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 and tails, tails, tails. There's your 6. But again, you still have 8 total possibilities. All right, if you flip a coin, Okay, try the rest, and I'm going to give you the answers, and we'll finish up here. Okay, so here's the answer for the rest of this page. 1 happening once out of 10 is 10%, but in reality, it should happen 1 out of 8. So that's a 12.5%, and you are only getting 10%. So again, they're doing less than what one would expect. Down here, chances to win out of the total, chances to win out of the total, chances to win out of the total. So this is your answer in fraction form. If you divide, there's your answer in decimal form, and then multiply by 100%